Hi everyone, I am Madam Rosmaya. In this video, we're going to discuss a question on magnetic field. Three long wires P, Q and R are arranged parallel with one another in a vacuum as shown in the diagram below. Given that the force per unit length between two wires, each carrying currents of 1 ampere and separated by 10 centimeter, is 2 times 10 to the power of negative 6 Newton per meter. So what is the magnitude and direction of the resultant force per unit length experienced by wire R? Magnitude is 3 times 10 to the power of negative 6 Newton per meter and direction is upward. Answer B, magnitude is 3 times 10 to the power of negative 6 Newton per meter, direction downward. And C, 6 times 10 to the power of negative 6 Newton per meter and direction is upward. And D, 6 times 10 to the power of negative 6 Newton per meter and direction is downward. So what is the answer? Okay, we are going to find the magnitude of the resultant force by wire R. Okay, we start with these two wires first, Q and wire R. So we use grip rule to determine the direction of magnetic field by wire R. So direction of current is to the left, and the other fingers shows direction of magnetic field. And you draw the circle which touch the wire Q. So tangent to this point that the circle touch the wire Q is a direction of the magnetic field B. So we name it as BR because this is magnetic field experienced by wire Q, and the magnetic field is from wire R. Okay, next we use Flemings left-hand rule to determine direction of force. So start with the BR. So BR is into the screen. So the pointer finger shows the direction of the magnetic field by R. Okay, next direction of current is to the right, and therefore the force direction is upward. We name as FQ. This is force on wire Q, so we name as FQ. Okay, done for wire Q. Next, we find the force on wire R. So wire R will experience force will experience magnetic field by wire Q. So we use a grip rule to determine the direction of magnetic field by wire Q. So direction of current this way. Okay, therefore direction of magnetic field by the blue line here must touch the wire R, so that the tangent at this point is drawn into the screen. So we name it as BQ because this is a B or magnetic field by wire Q. And for wire R, we use Fleming's right-hand rule to determine the direction of force on wire R. So direction of B is into the screen. Okay, direction of current is to the left, and lastly direction of force on wire R is downward. So now joining together, we can see that both wire Q and R repel each other. So using the formula force on a wire, a current carrying wire or conductor, the formula is given by mu naught IQIR L per 2 pi D. So the mu naught is 4 pi times 10 to the power of negative 7. IQ is 2 ampere. IR is 1. And force per unit length means per 1 meter. So here substitute 1 meter into the equation. 2 pi, and the distance between the two wire is given 10 centimeter. So convert to meter. The answer is 4 times 10 to the power of negative 6 Newton. Okay, next we are going to determine the force between wire P and R. So R also will experience the magnetic field B by wire P. So we do for R first, same as before, using grip rule to determine the direction of magnetic field B experienced by wire P. So draw the circle, and tangent to the circle is into the screen. So therefore, direction of magnetic field by wire R experienced by wire P is into the screen. We name as BR. Okay, next we use Flemings left-hand rule. So direction of current, direction of B first into the screen, shown by the pointer finger. The middle finger shows direction of current wire P to the left, and lastly, direction of the B, direction of the force on wire P is downward. We name as FP. Next, we do for R using grip rule. So wire R will experience the magnetic field B by wire P. So it's out of the screen. Okay, direction of B is shown by the other fingers here. So tangent to the point here is out of the screen. We name this as BP because this is magnetic field B by wire P. Okay, next we use Fleming's left-hand rule. So direction of B is out of screen. Direction of current is to the left. Lastly, the force is upward. So the force on R is upward. Okay, this means that the wire P and R attract each other. So therefore, force on wire R is mu naught IP IR L per 2 pi D, and we substitute mu naught 4 pi times 10 to the power of negative 7, and IP is 1 ampere, IA is 1 ampere, and force per unit length means for 1 meter, and the distance between wire P and R is 10 plus 10 is 20 centimeter, convert to meter. So the answer is 1 times 10 to the power of negative 6 Newton. Okay, now we've done force on wire R, okay, by the pair of P and R, wire P and R. So now we combine both force on wire R. This is the second one. We calculate 1 times 10 to the power of negative 6 Newton. We name as FR2, and FR1, from the beginning we start to find force on wire R, which we get 4 times 10 to the power of negative 6 Newton. So these two forces, we can determine the resultant. So the magnitude of the resultant force per unit length, okay, the resultant here means that the FR1 is downward, FR2 is upward. So 4 minus 1, we get 3 times 10 to the power of negative 6 Newton per meter. And direction is downward because the force downward is larger than the force upward. So therefore, the answer is B. Magnitude is 3 times 10 to the power of negative 6 Newton per meter, and the direction is downward. Okay, that's all for the video. Thank you for watching.